Hello. Right. Well, it lives, at least partially. It's one of the leaving projects for ages. It does help if you actually put the data wise on that. I forgot what I forgot to. I think I got to the point of letting the processor run and check the decode by seeing if there was actually worth trying to talk to things. But I'd not put the links on to the actual Max 232. We'd also left some pull-up resistors off down here, which could have been causing spurious interrupts. So now, press that, you get an asterisk. Just clear the window so you can see it. Which is what it's supposed to do. However, when you actually try and give it a command, so memory view, so it's M, and it produces the space, then the address, and enter. It doesn't do anything. R should display the processor registers. It starts and then gives up, so there's something still not quite right. Going over all the pinouts where I'd missed the pull-ups, I checked all the other pins, and there is a line on the processor called VMA, Valid Memory Address, and that is actually supposed to be used as part of the memory decoding. Now, in the PAL, I'd got address lines from A15 down to A2 as inputs. A2 is not actually used in any of the logic equations. It only stops at A3 because it only decodes into 8-byte blocks. So I've replaced A2 by VMA. So what we need to do now is pull that chip, program the new version, and see if that works better. Because it could be that the memory is getting spurious enables and corrupting it. Not the EEPROM, that. Because it's a very fast memory compared to the original things, and a few nanosecond pulse could be enough to confuse things if it's just the timing's a bit off and it gets a spurious pulse whilst the address lines are changing. So pull that. Right, carry on, interrupted by phone call. Right, so programmer, plug that in. Oops, don't need that on screen. Right, and where's the programmer itself? There. So I need to load the modified program. I'm sure I did it before that. After that, rather. Where's the program gone? Nothing on that. Have I not compiled? I might have edited it and not compiled it yet. This program is a little bit weird. Right. So I've edited it. I haven't actually compiled it. Yes, I want to save it. Yes. Okay, that's compiled without errors. So hopefully now, if we go back to the programmer and load, you should have a certain more sensible time on it. (1716), that's more like it. That's from when I did it the first time. Now that's still got the old file on the screen there. So possibly see a change of bit pattern. Yeah, it's just slightly changed the bit patterns on the thing. Anyway, let's program it. Oh, it does help to put the IC in. Right, okay. So that's that. Minimise that again. Find the serial program, which is what I use called real term, which is free and works very, very well. Plug it in, see if it makes any difference. It made a difference, but it's not working anymore. Oh well. No. That's not the difference I was hoping for. Oh, well, so what's happened there? Okay, back to the drawing board. To be continued. Okay, continuing. I found out why it was completely dead after I tried that mod. I put a wire on the wrong pin. Put it on the right pin, it made no difference whatsoever. So I've done another mod now, which is reallocate the pin I was using for the main memory chip that are not fitted yet, which will take up the bottom 32K of the address space, because that's unused by the test, or the debug ROM and its memory and I/O, and use that to produce a gated write there, that memory write signal, which is simply the phase 2 clock and VMA and the read write line being low. So basically that's delaying the write signal until after the data bus and address bus have totally stabilised, because these memories are far, far faster than were available or in this type of size when this system was originally designed in the 70s. And I think it was just a timing glitch, which is what I thought I would try the other mod adding the VMA signal. It's just a timing glitch that was allowing false writes. So, I've done a couple of minor wiring mods to take the direct read-write signal from the CPU off the write line on these, well, both sockets. Instead, that only goes to the decoder PROM, or PAL rather, and the PIA, the original wiring as it was intended there. And now the write line to each of these comes from the gated write from the PAL. I realised that the chip select for that was actually redundant, because that takes up the entire lower 32K of address space, which means it's enabled when A15 is low, and it requires a low chip select. So all I've done is put A15 directly onto its chip select pin. Though I've not plugged anything in there, I've not tried that bit yet, although that's another step. But the result now is, if I press reset, I get the asterisk, as I should, up there on the real term. Give it an R for we've got to put caps lock on. It doesn't understand lowercase. That ROM is very, very simple and primitive. So I've got the caps lock on, or else it just sees the wrong character. Give it an R, bit of a delay. It does a register dump. M for memory, and an address, say A012, and it displays the contents of that memory. And you just press enter and it will step through each memory address in turn, displaying the content. And it wouldn't do any of this reliably before. It was only kind of taking the command and displaying 1 or 2 characters and giving up. I'm quite surprised it is working, because the serial interface is rather horrible, to put it bluntly. It was designed to work with 1488, 1489 series RS-232 interface ICs, and the receiver on the 1489 is open collector internally, So it could be overridden, even though it's directly connected from an output on the 1489 to an output on this. But, let me find the circuit. I'll show you. Oops, let me do that. It's trying to scroll things. Because I've also drawn out the circuit in the meantime, or partial, to try and get my own head around it and understand it again, because it's so long since I worked on it. Where are we going? CPO. Right, that's the wiring or connections as it was supposed to be, using separate 1488 and 1489 driver and receiver ICs that run off plus minus 12 volts. And I say it's got an output from the receiver, which would have been a 1489, connected both directly to the transmitter in, which just gives the loop back to the terminal, so it displays what key you've pressed, and it's connected to both an input and an output on the PIA, on A0 and A7. There's only a single communications wire, which means with this being a push-pull output, it's got to be overridden by the PIA output to actually send anything. It really needs a diode and a pull-up resistor to give it an kind of OR function to convert this receiver output into just a pull-up, so it can be overridden and pulled down. So either that or the other IC can pull it down, but nothing can force it higher other than the resistor, which should work better. But amazingly, it is working okay at the moment, and the PIA must have a lot more drive than the Max 232 to be able to override it. So anyway, it is working at the moment anyway, so I'm not going to complain too much. I don't have a clue why that's gone like that. Oh, that's it. It was just me trying to scroll stuff. Right, so that is apparently working. Let me reset again. Now, obviously, there's no I/O on this at all other than the serial port at the minute. My original machine, I built a video writer, I think it was called. It was a 24 by 40 text display that was in one of the electronics magazines, and I built a version of that, but added serial communications to it, so I could use it as a terminal. I had to build the keyboard electronics and stuff to go with it as well, and that's what I used on my first machines. So I was on a 40 by 25 display, just on a normal TV, or actually a little 12-inch portable TV. So what I need something to test this a little bit more, so I've just tried to hand assemble a little program. It runs it's written to run at A100, which is just above the memory that the debug ROM uses. That uses up to A080 or A07F or something like that. So A100 is well within that chip, because it's a lot bigger than the original stuff. The original one only had 256 bytes of RAM, so I'd only got 128 bytes spare to write programs in to start with. That should hopefully work. Of course, I've got no assembler. There's nothing but the memory loader, so I've got to type it in by hand and hope I get it right. So I'll try that and see what happens. Because what it should do is increment characters from capital A up through the ASCII set, through the capitals and then lowercase with a few characters in between, and then just keep looping. It just it counts up from 00 to 3E, because if it gets to 3F it rolls over, because it's been ANDed there. And it just takes that number out of where I've stored it, adds 41 and transmits it to the serial port using the routine in the debug ROM. So I'll see if I can get that in and see if it works. No, I don't know if it will. I don't even know if I've got it right. Cause I've been going through the. Oh, where's that? Hang on a minute. That's Just minimise that for a minute. I'm working through the listing in the 6800 Programmer's Manual and the MicBug source code. So I'm using that outer EE routine of the ROM, and I tried to hand assemble it from the machine code there, which is pretty much how I programmed the original one. So anyway, that's a long time ago. So I'm a bit rusty, to put it mildly. Anyway, see what happens. So A1, I'll go up. A1 0 0. Yeah, okay. So it's I don't know what's happened there. 0. It's only taking one character at a time, which is not right. I'm pretty sure that's not how it works. Oh well, back to the drawing board. Oh, no, it's that one. Let me find out where this is. Memory loader. Oh, that's for loading serial tape, paper tape format or whatever. It's the memory display. Where's memory display? Memory examine and change. There we go. So that's it. Let's see, you should just be able to type a 2-character value and it should change. Now it could be that I should be using 2 stop bits. I wasn't sure on that. I've got this set for 300 board, no parity 8 bits, 1 stop bit. It might need 2 stop bits, it might need 7 data bits even, I don't know. Try that. Let's reset again. Try again. So it's A1 0 0. I could just be going too fast for it. This is quite a slow response because it's bit banging serial. That should be 8. No, it's advancing immediately. Ah, do you have to put a space first? It didn't advance on the space. Ah, that's it. You put a space. Try again. You've got to put a space if you're going to change it, rather than just typing a new value. So let me clear that again, so we can see what's on screen. Press reset again. A1 0 0. 6 0 0 B7 A2 no. Forgot the space. No. Now reset doesn't clear memory, luckily. So A102 B70. So got that. A2 00 105 8B 41 yeah, even though it corrupted it back because I typed too soon. I think it took it. 817 BD E1 D1. Just try and change that size a little bit so it's not masking the bottom of that character. E1 D1 B6 2 0 0 D 4C 843F nice. So it again. I was expecting it to scroll. 843F B7. It's still doing it. Why? Right upon that. B7 A2 0 0 7E A1 05. Right. Reset. Let's get out of that. I'm sure there's a command to get out of it, but I don't always use offhand. So M A1 0 0. Just go through. 8600 B7 A2 0 0 8B41 BD E1 D1 B6 A2 0 0 4C 843F B7 A2 This is getting frustrating. B7 A200. This last instruction should be 7E A105. Yes, that looks good. Right, clear screen again. Right, so we've got the prompt. Now, I believe the command is just G and an address to go. Go to user's program. G, yes. Just G. So I want to go to A100. G A100. And nothing happens. Has it done anything? MA200. Yeah, it looks like that's incrementing, because that should have been written to 0 by that first instruction. That loads A with 0 and then writes it back to A200. The fact that that's got a value in it should mean that it's tried to run it. Try again. It's not gone back to a new asterisk, so it's doing something, but it's not doing what it should do. Or I'm not doing something I should be doing. I'm calling the wrong routine or something like that. 1D, no, it's exactly the same value, so it's maybe I've just made a mistake in the assembly, because I'm trying to remember how to drive the thing in machine code from something a long time ago. Where's the... I've lost it. Where's it gone? There. Strange. Right. Yeah, it doesn't like key presses too quick. It's only running at 300 baud. So, what could be wrong? And if anyone can see anything wrong, let me know. Add in the comments. But I can't offhand see anything obviously wrong unless I messed up on the machine code side. B6 jump subroutine. That should be an unconditional jump to an extended address. Oh, by the way, these in Motorola assembly, immediate means it's the value in the instruction that's being used. Direct means it's a local address, a relative offset from the current instruction. Index means it's using the X register, the index register, which is X, as a pointer to the memory address that's being used. And extended means it's got a full 16-bit value after it, built in the instruction, like with these, where it's using the memory address A200 as a direct address. Oh, direct, it's a long, extended direct address. And then there's a lot of them that are inherent. They don't need any extra data, like the rotates and things, shifts and rotates, or increment, negate, that type of thing. So, offhand, I have no idea. I'll have to scratch my head a bit, have another coffee or three, fuel my brain a bit, and see if I can what I can come up with. Or I might actually try to find an online assembler and put this in an online assembler if there is such a thing for 6800, and see what I get from that. Okay, so to be continued.